So in this video, we're going to graph a transformed logarithmic function, and I'm just going to do a couple of transformations. You know what, maybe I'll do one as a reflection. So I'm going to change this to be a reflection. So we're going to graph the function f of x equals negative 2 ln x minus 1. So I like to always start this by plotting just the base logarithmic function. So that's going to be y equals ln x. And this, if you recall, is actually equivalent to y equals the logarithm of base ex. And why that's important is because the base is always going to be one of our parent points. It's going to be that point at e and 1. So we know we have 3 points. There's that one. There's that point that's ever present at 1, 0. And then there's that point that's present of the reciprocal at negative 1. So I'll go ahead and plot these points here. So 1, 0 is an easy one to plot. E is around 3. It's in between 2 and 3. It's 2.7 something, something, something. So there's 1, there's 2, there's 0.7 something, 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 and there's about 1. And then there's going to be 1 over 2.7. It's going to be like 1 over 3. It'll be, I don't know, let's go with somewhere in there. So those are going to be my parent points. And I could actually just kind of sketch this function out. And this is y equals ln x. So now what I have to do is I have to apply transformations. And I'm going to apply my transformations in order. So this tends to be a value of a, meaning it's a vertical dilation and reflection. It's a reflection because it's negative, so it's going to reflect vertically. And it's a stretch because it's multiplication. So this is going to be the y coordinate is 0. 0 multiplied by negative 2 is still 0, so it's going to remain right there. The y coordinate is 1. 1 multiplied by negative 2 is going to go down to negative 2. And this one, the y coordinate is negative 1. Negative 1 multiplied by negative 2 is going to be positive 2, so it'll go up there. And so I could draw like a portion of my function, or part way graph, and you can see it's stretched. And this would be the graph of y equals negative 2 ln x. But that's not the one I want. I want negative 2 ln x minus 1, and so there's still one more step. And that one more step is, again, another vertical transformation. But it's a vertical translation, so every y value is going to go down 1. So this would go down 1. This would go down 1. And this would go down 1. In fact, every single point along this curve is going to go down 1, including on the asymptote. I'll draw my final graph now. Now, I didn't do so good drawing the end of it. It should have tapered very close. It should have actually maintained the exact same shape as the red graph. But this is my graph of f of x equals negative 2 ln x minus 1. Now, whenever I graph something, I want to make sure that I include its domain and range. So I'm just going to earn myself a little bit more room here. Maybe change the camera angle. Okay, that does it. So that's going to allow me to write my domain. So my domain here, you'll notice that I have an asymptote, and I only have everything to the right of my asymptote. So that means that my domain is x is an element of the reals, such that x is greater than 0, because it can be every single value to the right of 0. And my range, still checking if I have enough room. Well, my range, it covers the entire y-axis, so it's entire with respect to y. So we would just say that it's y is an element of the reals. And that's the range. And so that's graphing a transformed logarithmic function.